The intramolecular forces include network, ionic, and metallic. All these IMFs have high viscosity or the tendency to flow because they are all solids. They also have low evaporation rates, again because they are solid, so they would not evaporate as easily as liquids would. They also have high melting and boiling points because since they are solids, they are harder to be broken down. They also have high surface tensions, which is the property of a surface of a liquid that allows it to resist an external force. So because it is a solid, it will have a higher surface tension.
Network is a network of covalent bonds creating a very strong solid.
Ionic bonds are when a metal and a nonmetal bond together. The more charge it has, the stronger intermolecular forces it will have. For example, NaCl would be weaker than MgO because NaCl would have an overall charge of 2 and MgO would have an overall charge of 4. So it will require more energy to break down MgO than it would to break down the NaCl. If you don't know if a molecule is polar, you can find the difference of the electronegativities. If it's between 0 and 0.5, it's nonpolar. If it's between 0.5 and 1.9, it's polar. And if it's 1.9 or above, it's ionic.
Metallic bonds are how metal atoms are held together in a solid. They are basically positive ions floating in a sea of electrons.
The intermolecular forces include hydrogen bonds, dipoles, and London dispersion. Because they are liquids, they are not held together as strongly as solids are, so they would be easier to evaporate. They also have low melting and boiling points because they are not as strong as solids are, so they would be easier to break down. They have low surface tensions and low viscosities. Another IMF is poles. Polar molecules are molecules that have more electrons on one side of the molecule. The longer that they are, the weaker the poles are. Polar molecules are molecules that are not symmetrical and have more electrons on one side. In the diagram shown, HF, because there are more electrons by the F than the H, it is polar. The longer the structure is, the weaker the poles are. If you are unsure if it is polar or not, then subtract the electronegativities. If the difference between the electronegativities is between 0 and 0.5, then the molecule is not polar. If they are between 1.5 and 1.9, then it is polar, and if it is above 1.9, then it is ionic. London dispersion creates very weak and temporary poles from the natural movement of electrons. The longer the molecule is, the stronger the London forces are. So, in the picture shown, the longer chains of C's and H's is going to be stronger than the shorter one. Different IMFs are stronger than others. The strongest IMF is in network. After network comes ionic and metallic, and they are interchangeable, and depends on the case which one is stronger. After that comes H bonds, and then polar molecules, and then London. All H bonds are polar and have London forces, and all polar molecules also have London forces.